is the continuation of the previous week, previous chapter. Right, so here we will look into inferential statistics, chi-square, t-test, and analysis of variance, or also known as ANOVA test. Right. So inferential statistics type of a certain type of procedures which allows a researcher to make inferences. Right. Here you want to make, you as a researcher, right, or after you get your data and everything, right, you are here building inferences, generalizations, right, building arguments for your research based on your findings from the samples, right? So it is basically to draw about illusion about a population by examining your samples, right? Since you cannot investigate, you cannot research for your entire population, the samples would be tested, and also later would be, what you call generalization would be formed, right? Hypothesis would be tested as well, right? As a quantitative researcher, as a quantitative researcher, for instance, you would be needed to test your hypothesis, and also to identify if there are any relationship among variables, or you can reject them, right? Everything is guided by software tool, SPSS, and to make predictions. Right. Through statistical tests, researcher can conclude whether the hypothesis is acceptable or reject or null hypothesis. Right. So you would test whether the findings after testing them, right, whether they are accepted. Right? If not accepted, then you would be rejecting on what are the reasons that given in your research for rejecting or accepting them. Correlational statistic focuses on relationships. Let's say factor A has been influencing factor B, for instance. Factor B is influencing factor A, like that kind of relationships. And to identify differences or comparisons, we use ANOVA test, right? We'll look into each and every form of test, right? Aspects that influence a researcher to choose a statistical analysis, right? One is measurement scale, whether it's nominal, ordinal, or interval, or ratio, right? And then methods and characteristics of your own samples, right? And dispersion of scores in population and sample size. Right. Inferential statistics studies a sample of the same data, right? Distributive statistic is the data, describe the data, right, like display the data and so on, and also describe which is what, and then studies a sample of the same data for you to make inference, right, on your sample. Can skip this. Yeah. Alternative and null hypothesis. Let's say in when you have put your data into SPSS, and then after you run a test, then comes 0.05. Alright, so symbol is P, smaller letter P is equal to or less than 0.05. Then researcher would reject your hypothesis and accepts new hypothesis, that is HO and H1. Right, so if the 0.05 significant levels is not achieved, then the HO is retained, which means your hypothesis is accepted. Right. 5 steps of inferential statistics to determine if sample means originated from the same population, which means they are not crossovers. You are not comparing the samples from different population. Right, it is the same population. You are only testing one population. Let's say only in Hanjiang, not Hanjiang in KD, not Hanjiang and what else? USM, for instance. Right. H0 no difference between two means, right? Let's say sample A and sample B from the same population. There are no differences, right? So differences may be found because of sampling error, which means then you have to go back to the drawing board. You have to change your sampling method or change your samples. Right, so results stated in terms of probability that HO is false, findings are stronger, can reject HO, this need to specify HO and HO, right? Probability that sample means are different enough to reject HO, 0.05 or 0.1. right? Basically level of probability or level of confidence, right? If you cannot if the sample means are not different, right, maybe there's no significant difference, there are no much differences, then you don't have to reject HO, right? And then the steps, right, or computing calculated value, right? These all we'll look into the steps shortly, right? Testing your hypothesis, right? There might be other reasons for rejecting HO, not necessarily for the reason you hypothesized, and not only for rejecting your hypothesis, right? Could be testing is based primarily on sample means and not population means, which allows the possibility of making an error or wrong decision, rejecting or failing to reject HO. Right? So here we have two types of errors, right? One is rejecting HO when it was true and should have been accepted, right? If A equals to 0.05, right? Let's say you run your test through SPSS and then you get 0.05, right? Then there's a 5% chance of type 1 error where it should have because it did, but because it is not 0.05, then you are rejecting them, right? Type 2, accepting HO when it should have been rejected, right? If A has increased, the chances of type 2 will decrease, right? Basically inverted from type 1 error, right? So inferential statistics use sample data to evaluate credibility of hypothesis about population. Null hypothesis basically means that there's no difference between mean. If let's say there are one population, sample A, sample B, and within these two samples there are no differences, right? It is equal, right? Maybe the number, the average are equal. That is what we mean by no difference between means, right? Okay, we can skip this. We go to chi-square, right? A non-parametric test, right? Not based on any assumption or distribution of any variable. It follows a distribution known as chi-square distribution, right? So where we use to measure the differences between what you have observed and what you are expecting to achieve from your research, right? Basically, you are testing your hypothesis, right? And not for estimation, right? Not for like weighing and so on and so forth, right? So no rigid assumptions, and or in other words, it's only suitable for nominal and ordinal, right? So we have two types of chi-square test, right? One is goodness of fit test, which is to analyze differences between independent categories of a variable, right? Independent variables, and then second would be test for independent to analyze relationship between two or more categories in two variables, right? Single variable example, right? Three categories of interest. You want to find the differences between how many people choose high, average, and low, right? And then for independence, whether they are relationship, right? Whether male has high interest over football compared to females, that kind of test, right? Nominal order scale, random sampling, these are the requirements, right? Right, these are all examples, right? Null hypothesis, there are no differences in there. These are the null hypotheses that you have developed earlier, right? And then research alternative hypothesis says there are differences in the endpoint used by HCUC, and then you run an SPSS analysis, right? This is the steps which you can try for yourself, right? Right. So and then check if the minimum expectation, minimum frequency, or expected count when the results are generated in SPSS. The value of expected count has to be higher than 5 for each cell slot, right? See, everything is above 5, right? So the test, if lesser than 5, then you have to discontinue. But here, 5, right? Now more than 5, right? Here, 0.073, more than 5 as well, right? So in SPSS, value of P is 0.03, right? meaning that there's no significant difference between the brands of handphones of the HUC students, right? So therefore, null hypothesis is accepted. This is your null hypothesis, right? That is how you do your SPSS analysis. So similarly for independent, right? You follow the steps, right? And this will be your outcome, gender and the major subjects and so on, right? So you can reject your null hypothesis. T-test is for interval or ratio scale, only data that are normally distributed, right? More than, random sampling and normal distribution, as has been said earlier. Right, so these are the divisions of t-test which you can do for different types of data, right? Sample size with more than 10 subjects, dependent variables are measured in interval or ratio scale, right? Using histogram or test of normality, right? Right, one sample t-test is to compare the mean score of a sample with the mean score of population, right? The average number of your sample, which you have already extracted from your population, and then the mean score of your entire population, the average number of your population, right? Must be more than 50, right? So example, PT3 students, they will see into SPSS, right? And then you run your SPSS test and comes as value of P is equal to 1.000, right? And a significant difference of rate of students school A. Independent sample t-test, because both groups are not dependent on another or independent from another, right? So two different samples that are not directly linked, like group of students who have a divorced and not divorced parents, right? The parents are not directly dependent on one another, right? There are two different groups that are independent from one another, right? Null hypothesis, right? These are examples, right? Run your analysis and then you develop your what do you call your analysis, right? And then paired sample t-test, similar with repeated t-test, only the research methods are different. In paired sample t-test, the second sample has similar characteristics of the first sample, right? Right, the second sample has similar characteristic of the first sample, for example, right? The research intends to identify the difference of rate before and after consuming fruit juices among housewives, right? Housewives of, let's say, from Penang and Johor Bahru, for instance, right? And they have similar characteristics, housewives, right? Married, maybe age groups and so on and so forth, right? So the null hypothesis is developed, and then you are testing your null hypothesis, right? And then once you got value of P is 0.0000, which means there are differences of rate between before and after the consumption of fruit juices among housewives, right? So below 0.5, right? So null hypothesis is rejected, right? Repeated t-test is used on a group of dependent samples that exist in pair and intends to compare the mean value of both sets from the same group of samples, right? Comparing mean value of your examination scores, like your examination scores, right? I have 3 different from the same group, which means same samples, right? But I'm comparing their marks from different semesters, from different exams, but same person, right? Will therefore have, let's say, for example, you will have 3 different scores, right? If you have 3 different exams, right? So identify differences between the means, right, of the different data set. Maybe for the first semester group of 20 people, the average score, and then second exam group of 20 people, average score, and then the final exam group of 20, the average score. Then I compare the 3 differences, if the 3 means if there are differences, right? Or we have an example, right? So ANOVA test, right, used to determine whether there are statistically significant differences between the means of 3 or more independent and related groups, right? So it increases the number of independent groups, It checks the impacts of one or more factors by comparing the means of different samples. So as of now, you would have already seen that all the statistical analysis, right, they are functioning to test the means, right, if to find your variables have significant impact, right, whether your objective can be found or not, right. So this is an example, all right. So important grand mean, this all you can figure, right. Not here, here, yeah, one way or two way and over, right. This is important because you have to decide which one you want, right. So the number of independent variables in your analysis, right, how many independent variables there are in your research for you to decide which kind of which kind of NOVA test you want to conduct. Right, one way has one independent variable with two levels, for example, brand of cereal. Two way has two independent variables, it can have multiple levels, for example, brand of cereals and calories, right? So groups or levels are different groups within the same independent variable, right? Brand of cereals, blah blah blah, all right? And then levels could be calories, might be sweetened, unsweetened, and total of two levels, right? Couldn't be more than that. Total of two levels, right? Here, what do you say? Two ways can have variables can have multiple levels. Only if one way has one independent variable with maximum two levels of with two levels, right? And then if you're studying, let's say if you're studying an alcohol support group and individual counseling combined with most effective treatment, right, for lowering alcohol consumption, right? Might split the study participants to medication only, those who only seeks medication and medication counseling 2 level, or counseling only. Then you may use one way ANOVA, right? Two way ANOVA with replication. You have two groups and individual within the group that are doing more than one thing, right? Group of students from two colleges taking two tests. If you only have one group taking two tests, you would use without replication. Right? You don't have to replicate them, repeat them. Right? You are comparing two independent groups using their distribution. So the null hypothesis for test that two means are equal, therefore a significant difference means the two means are unequal. Right? The example, right? Right, so it will basically, the limitation is that one way ANOVA can tell you at least two groups were different from each other, but it won't tell you which groups were different. Right, you cannot specifically pinpoint. If your test returns a significant F statistic, you mean to run an ad hoc test like least significant different tests and to tell you exactly which groups have a different entity. Right. Two-way ANOVA, they have two independent variables, right? When you have one measurement variable, example, a quantitative variable, and two nominal variables, right? If your experiment has quantitative outcome and you have two categorical explanatory variables, maybe a two-way ANOVA is more appropriate. Right? For example, you want to find out if there's an interaction between income and gender, right? For anxiety level at job interviews, right? So there are 1, 2, 3, 4, right? So two different variables, right? Here one, right? Anxiety level is the outcome or the variable that can be measured. Gender, income are the two categorical variables. What do you call? These categorical variables are also the independent variables, which are called factors in two-way ANOVA, right? This the what do you call? The examples and the steps to be followed in this as well, SPSS as well. Value of P, right? Value of P is 0.653, right? And then there are differences between weight loss with diet and different eating pattern, right? So that would be it. All right, thank you.